Let's solve this system of rational equations. The first step will be to set these equations equal to each other since they both equal y. So that's going to be 5x over x plus 4 equals 2x minus 1 over x. Now, there are many ways to solve an equation like this. I could cross multiply, but the method I like to use is to make the denominators the same. The reason why I like that method is because it's the same way we add and subtract fractions. It really works on any rational equation, so it's the most useful. So I see that the left denominator has an x plus 4. So I'm going to multiply by x plus 4 in this denominator, which is okay as long as I multiply the numerator by x plus 4. Now the right denominator has an x, so I'm going to multiply the left denominator by x as well, which is okay as long as I multiply the numerator by x. Now you see that I have x times x. You know that's x squared. So let's not play around. Let's put x squared. Now before we go any further, we should mention the excluded values. X cannot equal negative 4 because of the x plus 4. Set that equal to 0. X cannot equal 0 because of the x. Just keep that in mind for later. Now, since the denominators are the same, we can now throw out those like denominators and make a new equation using the numerators. So I have 5x squared equals. Now I'm going to have to double distribute here. So 2x times x is 2x squared. 2x times 4 is 8x. Negative 1 times x is negative x. And negative 1 times 4 is negative 4. So that's 5x squared is equal to 2x squared plus 7x minus 4, combining like terms. Anytime I have x squared and x in the same equation, I'm going to get 0 on one side and try to factor, or use the quadratic formula. So I can get 0 on one side by subtracting 5x squared from both sides. So that's going to give me 0 is equal to negative 3x squared plus 7x minus 4. Now I'd like to factor this, but it's really inconvenient to have the leading coefficient be negative. That is easily solved by dividing both sides of the equation by negative 1. So I'm going to wind up dividing each term by negative 1. So that's just going to change all the signs. So I have 0 is equal to positive 3x squared minus 7x plus 4. Now my leading coefficient is positive, and I can factor more easily. So 3x squared will factor as 3x times x. 4 is either going to be 2 times 2 or 1 times 4. Now I'm trying to look ahead. Let me just show you what happened. So I don't think the 2 and the 2 is going to work. But here's why. Inner plus outer must equal the middle. Inner, I have 2x, and outer, I have 6x. The middle is negative 7. There's no way I can get a negative 7 out of 2 and 6. So that's why the 2 and 2 option is not working. So that leaves 1 and 4. Now it does matter whether I put the 1 here and the 4 here, or the 4 here and the 1 here. I'm looking ahead and I'm thinking it's going to work best if I put the 4 here and the 1 here. Again, inner plus outer equals middle. Inner, I now have 4x. Outer, I have 3x. To get negative 7, both of these would have to be negative, which means both of these would be negative. And fortunately, a negative times a negative is a positive 4. So this is good. Now we can get the solutions by setting these factors equal to 0 and solving. Adding 4 to both sides, I have 3x equals 4, and then dividing by 3 on both sides, x is equal to 4 over 3. Adding 1 to both sides, x is equal to 1. Now, we are not finished here, people. These are just the x values. This was a system. Alright, we started off with two equations that involved y values. That tells us that we need to find the y values as well. Alright, so our x values are 4/3 and 1. How do we find the y values? Well, we will use one of these two equations. It doesn't really matter which. Which one looks simpler to you? Honestly, they both look equally simple to me. I think I'll just use the top one. So y is equal to 5x over x plus 4. Now, I have the option of either substituting these values in for x myself, or I can use a calculator. It's easy to substitute in 1, so I think I'll show you how it would work if I do that by hand. By the way, notice that neither of these are excluded, so that's good to know, but this is in my way. I'll do this 1 by hand, but this fraction I'll use a calculator. So if I substitute 1 in for the x's, that gives me 5 times 1 over 1 plus 4. That gives me 5 over 5, which equals 1. So now I have 1 comma 1. Now I'm going to use my calculator for the other one because it would be a little tedious to substitute in the fraction inside of a fraction. So here's how I would do this on a calculator. I would go to my table function, and I would type in this function. So 5x over x plus 4. So let's see, 5x over x plus 4. Alright, make sure you're in AskX mode, and then we're evaluating at 4/3. So 4 over 3. Boom. That is 5/4. So there you go. And while I'm here, let's see what if I put in 1. And there's the same 1 comma 1 that we got by doing it by hand. So these are the points that we need. And that seems to match option B. 4/3, comma 5/4, and 1 comma 1.